For decades, scientists have found thousands of planets outside our solar system without ever actually seeing them. They detected shadows, they detected wobbles, they detected tiny dips in starlight, but they had never simply pointed a telescope at empty space and watched a brand new planet reveal itself in a photograph, until now. In June of 2025, that changed, and when researchers finally confirmed what they were looking at, their reaction was pure disbelief. This is the story of the first planet ever discovered by actually being seen. If discoveries like this fascinate you, hit subscribe now, because we break down the most groundbreaking moments in space exploration every single week. To understand why this moment mattered so much, you first need to understand just how hard it is to photograph a planet. Stars are blindingly bright. Planets, by comparison, are incredibly faint, reflecting only a tiny fraction of their star's light, or in some cases, glowing faintly with their own leftover heat. Trying to photograph a planet next to its star has been compared to trying to photograph a firefly sitting directly next to a lighthouse beam. The overwhelming glare simply drowns out anything faint nearby. Because of that challenge, astronomers have spent nearly 30 years finding exoplanets almost entirely through indirect methods. The most common technique, called the transit method, watches for a tiny repeating dip in a star's brightness as a planet passes in front of it. Another method tracks the subtle gravitational wobble a planet causes in its star's motion. Both approaches work brilliantly. Scientists have confirmed nearly 6,000 exoplanets this way, but neither approach actually shows you the planet. You're inferring its existence from indirect clues, not looking directly at it. Direct imaging, actually capturing a photograph of a planet, is the rarest and most difficult method in the entire field. And until recently, every single exoplanet ever photographed had already been discovered first through some other method. Astronomers were essentially confirming planets they already knew were there. Nobody had ever pointed a telescope at a star, taken a picture, and found a completely unknown planet staring back for the very first time. That's exactly what happened next. Like this video right now, if you didn't realize how rare it is to actually photograph a planet, because what scientists found next had never been done before. The team behind this discovery, led by astrophysicist Anne-Marie Lagrange at the French National Center for Scientific Research, set their sights on a young star called TWA-7, located roughly 111 light-years from Earth. TWA-7 is only about 6 million years old, practically a newborn on cosmic timescales, and it's surrounded by a dusty ring system, a debris disk left over from its formation, not unlike the disk that once surrounded our own sun billions of years ago. Researchers specifically chose to study TWA-7 because it could be viewed almost directly from above, giving them a clean, bird's-eye view into the system, rather than looking at it edge-on where a bright disk would block their view. That debris disk had already been mapped in detail, and it contained 3 distinct rings, with visible gaps between them. Gaps like that are exactly where astronomers suspect hidden planets might be lurking, since a planet's gravity can carve out empty channels in surrounding dust and debris as it orbits. In June of 2024, the James Webb Space Telescope turned its attention toward that gap, and using an instrument called MIRI, the mid-infrared instrument, equipped with a specialized coronagraph, essentially a mechanism that blocks out a star's overwhelming light the way your hand blocks sunlight when you shield your eyes. Researchers began the delicate process of trying to see what, if anything, was hiding in that dusty ring system. Don't forget to subscribe before we get into what they actually found, because the numbers involved are genuinely remarkable. After carefully subtracting out the residual glare from the star itself, using advanced image processing techniques, a faint source of infrared light emerged in the data. It sat almost exactly where theoretical models predicted a hidden planet might be, nestled in the gap between the first and second rings of the debris disk. Researchers designated it TWA-7b, based on its brightness and the physics of how young planets cool and glow after formation. The team estimated TWA-7b has a mass roughly similar to Saturn, and orbits its star at a distance about 52 times farther than Earth orbits our own sun. That's an enormous distance, far beyond where any planet exists in our own solar system, and it made this discovery, if confirmed, the lightest planet ever detected using direct imaging outside our solar system. Of course, scientists don't just accept a single faint smudge of light as definitive proof of a planet. The team ran the numbers to rule out other explanations, most importantly the possibility that they were simply looking at a distant background galaxy that happened to appear in the same part of the sky. After careful statistical analysis, researchers calculated the odds of that happening by pure chance at roughly 0.34%. In other words, they were about 99.7% confident. This wasn't a coincidental galaxy sitting in the background, but something real, physically connected to the TWA-7 system itself. Here's why this moment left even seasoned astronomers stunned. Make sure you're subscribed, because understanding why this is different from every previous exoplanet discovery is the whole point of this story. Every direct image of an exoplanet captured before this one, and there had been a handful using both ground-based telescopes and Webb itself, showed planets that scientists already knew existed. Those worlds had been found first through other detection methods, and the photographs came afterward, essentially confirming something already suspected. WA-7b was different. This was the first time in the history of exoplanet science that the act of taking a picture is what discovered the planet in the first place. Nobody knew TWA-7b existed until Webb's camera revealed it. Lead researcher Anne-Marie Lagrange described the core challenge of this kind of work in strikingly simple terms, explaining that the basic problem researchers face is that the star is bright and the planet is incredibly faint. Overcoming that imbalance, using nothing but a specialized coronagraph and painstaking image processing to reveal a completely unknown world for the first time, is precisely why this result was published in the prestigious journal Nature, and why it made headlines across the scientific community almost overnight. There's a deeper significance here too, beyond just the technical achievement. TWA-7b sits within a young dusty debris disk, the exact kind of environment scientists believe planets form inside of. By directly observing a planet nestled in a gap within that disk, researchers gained rare, real-time evidence supporting exactly how theoretical models predict planet formation should look. Rings of leftover material slowly clearing out as young planets sweep up debris along their orbits. This discovery also demonstrated something crucial about Webb's own capabilities. The telescope's coronagraph, developed in part using French-built technology on the MIRI instrument, proved sensitive enough to detect a planet far lighter and fainter than anything directly imaged before it. That's a significant technical milestone because it suggests Webb may be capable of directly photographing even smaller, fainter worlds in future observations, worlds that would have been completely invisible to earlier generations of telescopes. It's worth remembering just how young this entire technique still is. The very first direct image of any exoplanet was captured back in 2004 using ground-based telescopes showing a large, young planet orbiting a brown dwarf. In the 2 decades since, astronomers have directly imaged only a small handful of exoplanets, a tiny fraction, compared to the nearly 6,000 confirmed through indirect methods. Every single direct image added to that short list represents an enormous technical achievement, and TWA-7b, as the very first planet actually discovered through direct imaging, occupies a unique place in that short, exclusive history. Researchers have also been refreshingly honest about the work still ahead. While the statistical evidence strongly favors TWA-7b being a genuine planet, the team has stressed that additional observations are needed to fully confirm its nature and better understand its orbit, its atmosphere, and its precise mass. That kind of careful, methodical follow-up is standard practice in a field where a single misidentified data point could lead an entire community of scientists down the wrong path. Still, the significance of this moment hasn't been lost on anyone in the field. For years, astronomers have talked about exoplanets almost entirely in abstract terms, plotted as data points on brightness curves or represented as tiny wobbles buried in years of positional measurements. TWA-7b represents something different, a planet that essentially introduced itself to humanity for the first time, not through inference or mathematics, but through an actual photograph, faint and imperfect as it may be, showing a real world orbiting a real star, 111 light years from where you're sitting right now. Scientists studying planetary formation are already planning follow-up observations of the TWA-7 system, hoping to learn more about the planet's atmosphere and confirm details about its orbit within the debris disk. And astronomers across the field are watching closely, because if Webb's coronagraph can detect a world this faint and this small, it raises an exciting question about what else might be waiting, quietly hidden in the gaps of other young star systems, simply waiting for someone to point a camera in the right direction and finally take the picture. Let's talk a little more about how a coronagraph actually works, because the technology behind this discovery is almost as fascinating as the planet itself. A coronagraph is essentially a precisely engineered mask placed inside a telescope's optical path, designed to block out the light of a central star while still allowing faint light from nearby objects to pass through and reach the camera's sensors. The concept sounds simple, but the engineering is extraordinarily difficult. Starlight doesn't behave like a clean, single beam. It scatters, diffracts, and bounces around inside the telescope's optics in ways that can easily overwhelm anything faint sitting nearby. Building a chronograph, sensitive enough to suppress that glare by a factor of thousands, and while still preserving the incredibly faint signal of a planet, a fraction of its star's brightness, represents one of the most demanding engineering challenges in modern astronomy. The specific coronagraph used for this discovery was developed in part through French aerospace research, integrated directly into Webb's MIRI instrument, and its performance during this observation exceeded what many researchers expected going into the project. That's part of why this discovery matters beyond just the planet itself. It's proof that this specific technology works exactly as intended, under real observing conditions, on a genuinely unknown target. It's also worth putting TWA-7b in context alongside the broader search for planets like our own. Most planets discovered through direct imaging tend to be large, young, and glowing with leftover heat from their own formation, similar to how a freshly forged piece of metal glows before it cools. That's part of why direct imaging tends to favor massive, Jupiter-like or Saturn-like worlds early in their lives, rather than small, rocky planets like Earth. TWA-7b fits that pattern closely, a young Saturn-mass world still radiating warmth from its recent formation, orbiting a star that itself is barely out of its own stellar infancy. Scientists are quick to point out that this doesn't mean Webb is on the verge of directly photographing an Earth-like planet anytime soon. Rocky, Earth-sized worlds are dramatically fainter and sit far closer to their host stars, making them exponentially harder to separate from stellar glare using current coronagraph technology. But every technical milestone, including this one, pushes the field incrementally closer to that eventual goal, refining the instruments, the image processing techniques, and the theoretical models that future, even more advanced telescopes will rely on. There's a broader historical thread running through this discovery too. Confirmed exoplanets have only existed as a documented scientific reality since 1992, when the first planets were discovered. Orbiting a pulsar, followed shortly after by the first exoplanet found orbiting a sun-like star in 1995. In just over 3 decades, the field has exploded from a handful of confirmed worlds to nearly 6,000, to transforming from a speculative frontier into one of the most active branches of modern astrophysics. Direct imaging, throughout that entire history, has remained the rarest, most technically demanding piece of that puzzle, precisely because it requires overcoming the fundamental physics of trying to see something faint sitting immediately next to something extraordinarily bright. That's exactly why researchers describe this particular discovery as a landmark moment, not because TWA-7b itself is an especially unusual planet in terms of its size or composition, but because of how it was found. It represents a genuine first, a moment where a telescope's camera, rather than years of indirect measurements, became the tool that revealed a previously unknown world. Anne-Marie Lagrange and her team have continued analyzing the data since the initial announcement, working to refine estimates of the planet's exact mass, its temperature, and its precise orbital characteristics within the debris disk. Additional observing time with Webb has also been proposed, with astronomers hoping to capture the planet again using different filters and instrument modes, which would help confirm its nature beyond any remaining doubt and potentially reveal details about its atmosphere as well. For now, TWA-7b stands as a quiet but historic milestone, a faint point of light in a young star's debris disk, sitting 111 light-years away, that became the first planet in human history to be discovered simply by being photographed. Every exoplanet found before it was inferred, calculated, or indirectly measured. This one was simply seen. If this story changed the way you think about how we find new worlds, make sure you're subscribed, because there are more groundbreaking discoveries like this coming every week. Hit like, drop a comment telling me what other unseen planet you'd want scientists to photograph next, and I'll see you in the next video.